Okie doke. Got another one here, number 19, that is a little maybe less complicated than it looks. Okay, so we're supposed to know which one of these are equivalent to the fourth root of 81x to the 8th over y to the fourth. Okay, so what I would suggest doing first is simplifying this. Okay. So to do that, we need to know fourth roots. Perfect. So 2 to the fourth is 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 to the fourth is 81. So what does that mean about the fourth root of 81? Okay, let's look at that, because I think sometimes we have a little misunderstanding of what we're really doing. Okay, if 3 to the fourth is 81, watch what happens when we take the fourth root. Take the fourth root of both sides, golden rule of algebra. The fourth root and the fourth power will cancel each other out, and 3 is the fourth root of 81. So when you see the fourth root of 81, that's just a 3 in disguise, a complicated 3. It's being very extra. Okay, so we can bring a 3 out. Then we have a fourth root of x to the 8th. Let's rewrite that as a power, in exponential form. I like writing my variables in exponential form because I think it helps out a lot. So a fourth root is a fourth power. Fourth root, 1/4 power. Okay, so x to the 1/4. Multiply those exponents and you get x squared. Okay, so an x to the 8 under a fourth root is really just an x squared. Okay, and then we have something in the denominator. That would be, if you wanted to put it up in the numerator, you'd make it y to the -4. And it's also being raised to the 1/4 power. When you multiply those, you get y to the -1, or just a y to the first in the denominator. Okay, so that expression up there, although it looks complicated, is really just 3x squared over y. Now, let's look at the options. What we're going to have to do is, I'm going to look at just the coefficients, right? So I know I need to get a 3 as my leading coefficient here. So if I'm taking the fourth root of 9, that's not 3. So that's not it. Fourth root of 81, that could be, fourth root of 81 we already know is 3, so that could be true. What about the cube root of 21? That's, the cube root of 21 is 3, so that could be true. The square root of 9 is 3, so that one holds. But the square root of 27, nuh-uh, not 3. It's a little more than 5. Okay, so immediately, just by looking at the numbers, just by looking at the coefficients, we have narrowed down to these middle 3. The ones on the end can't work. So now let's look at the x's. It's not going to be very helpful, but we can look at the x's. So like in this first one, I have x to the 8th being raised to the 1/4. We did that earlier, same thing, fourth root of x to the 8th, and you get x squared. So that one could still be it as far as the x's are concerned. Here we have an x to the 6th being raised to the 1/3 power. That'll simplify to x squared. That one still works. X to the 4th on this one being raised to the 1/2. That's also x squared. So the x squared business doesn't simplify anything. Okay, and if you notice, they're all in the numerator, and the x to the 8th in the original problem was in the numerator. So a little tip off there. Now look, the y to the 4th is in the denominator, okay, or the y once we simplified it. So look at this second one. We have a y to the 4th being raised to the 1/4. That's a y to the first power, but it's in the numerator. It's not in the denominator. So no. This next one, you have a y to the third power in the denominator. So if I wanted to put it in the numerator, I'd make it -3. And it's being raised to the 1/3. So that's y to the -1, or 1 over y. And that's what I needed, a y in the denominator. So that does simplify to be 3x squared over y. And then this last one, I have a y to the -2 right there. So all I'm doing is just moving that to the numerator. and it's under a square root, which is just a fractional exponent. And that's y to the negative 1, or 1 over y. And so that one also works. Here's number 19, just 2 more.